Okay, I think everybody's here. So today and Tuesday, we're going to have amazing speakers. So Vince Giuliani, and Coehlo. He is a psychologist, graduated from Harvard back in 1959. He spent the last 70 years studying a lot of topics, but most recently he studied longevity and the whole idea of how to live longer and the concept of younging. And he's discovered things that the general medical community has no idea about. And then Steve Buss is a researcher that's gone through the last 10 years of putting together an amazing review of literature on longevity. And so both of them have worked together and have given presentations. They've discovered things that I never heard about until then. So I asked them to kind of go through their thinking process and to give you the latest.
So, I'm Steve Buss. I'm software engineer with Ben. And my colleague, Vincent, will they be able to see him? Maybe not. So maybe we could put, oh, I know what to do. Let's see. Oh, when he's talking, I'll move his picture over. Vincent is in Wayland, Massachusetts, and our talk today is about looking to the future on longevity 1. Now, let me tell you first. Let's see, I press a little bit about myself. I am a software engineer. I'm a cognition and biohacker, and I am the organizer of the Ben Big Picture Book Club meetup. I also blog about longevity science at longevity.org, and I've been blogging about the 2 mechanisms we'll talk about in the next few days for 4 and 10 years. I'm also a fallibilist. I believe finding error is the key to making progress in learning about anything. Vincent is 92 years old. He's been blogging about anti-aging firewalls, about rejuvenation and how to slow or reverse aging for 12 years. His blog has 125,000 registered subscribers. It has 650 articles, and it's journal grade, quality standard sorts of articles. And at 92 years old, he's done a lot of things in his life. He got a PhD at Harvard in computer science in 1959. I was 4 years old then. And if you look at his site, you'll see it covers everything about health and longevity, just about. We've been collaborating about 2 years now, and for the last year, we're not scientists who do experiments. We don't raise rodents and do experiments on them. We read abstracts, and we try to figure out how the detailed knowledge in scientific studies comes together to paint a picture of what aging is about, and more importantly, what rejuvenation is about. Here's what we're going to cover. We're going to cover a large scope, different levels of abstraction and detail. Vince is going to talk first for about 20 minutes about background on aging, consequences of aging. And then I'm going to talk about the aging knowledge puzzle and something called the cholinergic anti-inflammatory pathway. We think CAP, the cholinergic anti-inflammatory pathway, is among the 2 most significant things that can impact your health and longevity, which most people don't know anything We'll talk about it in general, what it is, and we'll talk about it and evidence and how it increases survival probability. And then we'll talk about interventions briefly, and then summarize and do Q&A. Also, we're gonna talk about two mechanisms that are fundamental for aging and rejuvenation. We're gonna talk about the mechanisms at a high level and in general, and then we are scheduled to talk about interventions, that is how to trigger these two mechanisms, on April 9th at 8 a.m. for the London Futurists meetup. Here's a picture of the meetup announcement here. And all right, let's see. Okay, Vince. Vince, you need to unmute yourself. Vince will take it away.
There we go. Aging affects just about every area of human biology, and every area of human biology impacts on aging. And as Steve pointed out, our research laboratory is the collective knowledge represented in publications. There's a government organization called PubMed.org that has about 21.5 million publications related to science and medicine. And every year there's about 1.3 million new publications added to that. This is our research laboratory. We don't have rats, we don't have mice, we don't have hospitals, and we come from areas outside of conventional biology or medicine. And this means that there's certain knowledge we were not trained in, but it also means that we have our minds open in ways that we think are important. Let's go
Vince,
on.
hold on. Vince, hold on 1 second. Sorry.
You could go to the next slide, Steve.
Okay, well, hold on, Vince. We want to try to show you on the screen somehow. Oh, I was trying to make it smaller. We can go here. Let's see. Oh, there we go. Is that better? Oh, and I think we can make spotlight for everyone.
We're a little bit back into 1970s where we used to say, the next slide, please.
Here we go. Okay.
What I want to say is that research is very different now than it's been traditionally for decades and decades. We communicate online. I'm online with Steve or by voice, hands-free voice, practically every day, sometimes multiple times a day. People work from wherever they are. There's video conferencing, and the efficiency of communication and research is much better than it's been traditionally. Next slide. Physics has a reputation of being infinitely deep. This is a lecture on quantum mechanics. But on the other hand, they say biology is infinitely complex. This is one of the many diagrams of processes going on in biology. Next slide. Here's another one. These are related. This one has to do with purine metabolism. Each of those boxes represents a step or a process. Let's go to the next slide. Here is another one that relates to aspects, I believe, of cancer metabolism. Next slide. Here is another one. And you begin to get the idea that this complexity is incredible. It is so complex and so deep that people in one area of specialty literally cannot understand what people in another area of specialty are doing. Next slide, please. Here is one on aspects of inflammation and showing inflammatory. This one has to do with infected liver tissue. Next slide, please. Here are more slides, and there are thousands of these diagrams that are in the literature, not all consistent, not all actionable, but solid in great depth and complexity. Next slide. The result of this complexity is that researchers in one area don't understand or even care about what researchers in another area are doing. They haven't got time. Now, about aging, it's very multi-layered. It's a result of complex changes throughout the body on every level, from the molecular pathways to the cell level, to the organ level, to the tissue level, to whole body systems. And on the other hand, it's usually studied because of the nature of academia in terms of great depth, research papers that drill down into fine details. They're focused on very concrete specifics. So because of this, the research, next slide, tends to be reductionist, like most things in the West are, and highly focused. This traditional strategy has led to us building up, as I mentioned, more than 21 million in-depth research articles, which are a rich treasure for researching just about any topic in medicine, health, and longevity. And Steve and I conjecture and believe that the solutions to many of our current issues of aging and longevity, many of the problems being researched in one area are already solved by scientists in another area. We have examples we've come across that. And, you know, one way I view this is that if you ask, what would I like to have if I wanted to be a highly effective longevity researcher? And my answer is, first, access to this incredible knowledge base as a source of research. And secondarily, it would be nice to have a laboratory with 300 or 500 scientists doing in-depth studies that we directed. But that's secondary to what we've been doing. Let's go on. Next slide. So that most of this work, as I said, deal with specific aspects of specific diseases. The role of purine metabolism in colorectal cancers, and don't seem to shed much light outside their specific areas. So a more integrated research, that's what we've been trying to bring. Next slide, please, Steve. So how does science speak with regard to aging? Well, first of all, with many different tongues, depending what area of science you're involved in. Click next, please, Steve. Important scientists can come, applicable to aging can come from cancer research, Alzheimer's disease research, genetics, studies of animals, in many cases, studies of plants, veterinary science, population studies and aging research studies. Next slide. And they can come from anywhere in the life sciences. Next slide. They can be inconsistent, pursuing different hypotheses. Next slide. Altogether, we have what amounts to being a traditional Tower of Babel. The contributed work is excellent, but people don't talk to each other very much. Next slide. You can see this in this illustration of an elephant. If you ask longevity scientists, what are the best ways to extend lifespan and rejuvenation? You can have these answers, lengthen telomeres, remove senescent cells, reduce inflammation, repair the damage.
I couldn't find citizen cells reduce on your list.
Alexa, quiet. I have Alexa here. So that actually understanding aging takes us into an adventure of life sciences. Next slide. What's important, one important thing to understand about aging is that our views of it have changed, as have history. The lower curve on the left, called 900, is how things looked at the age of 900. These are survival curves. And as if you can see, by the age of 20 or 25, half the people have died in that curve. And by the age of 60, maybe only 10% were still alive. By 1900, this curve had changed and people were living longer, but the maximum was still the same. And by 1920, it was longer yet, until we get to the curve around 2020, which you can see in red, and we're living longer, but we're still dying by the age of 122. As a matter of fact, there seems to be an age speed limit of 122 years for human beings, and nobody lasts longer than that. Next slide. As time goes on, these curves keep getting higher and higher, and more people are living towards the maximum age until we might get to something like curve E, where everybody lives to close to 120, and you have people asking me for a meeting, and I say, I can do it Wednesday, but I can't do it Thursday because I'm scheduled to die Wednesday afternoon. It's literally that much. Next slide. Now, how about that 120 years maximum?
One quick question. Is everybody familiar with the basics of survival probability curves? What you have, just to be sure, what you have on the y-axis is 100% at the beginning of the study or the analysis, 100% of the participants are alive. And here is 0% alive. That means everybody's dead. And then you have various curves plotted within this grid, and you can have any number of interesting independent variables driving the survival probability curve over time. Next slide.
Okay. This curve is being rectangularized, as it says. It's looking more and more like E. Let's go on now. Next slide. As this slide shows. So it's important to mention where this longer longevity is coming from. Is it coming from medical science? No, mainly not. Is it coming from longevity research? No. It's come mainly from social developments that have public health, like our streets of London in Dickens' times, up to then, and in many cities in the third world, the streets are littered with garbage. Until we got automobiles, there was horse shit everywhere and biological contamination. The water was not safe. The air was polluted. And even in recent times, the aging extension has been due to things like cleaner air, less smoking, vaccinations, that is a medical one, and fewer wars. So what we do socially affects our biological lifespans and affects our biology. Evolution goes on, but a lot of that is social evolution. And what we're about, Steve and I, is trying to further that social evolution. Let's go on. Just a little bit about maximum lifespan. This seems to have to do very much with the species. There are certain species of bacteria that will only last for an hour unless it's fed or multiplies. Mayflies typically last a day, shrews 2 years maximum. House mice, 1 year typically. There's different species of mice, some live 2 years. The naked mole rat looks like it's about the same size as a mouse, but they live 17 years. A really long-lived dog can go 23 years, and surprisingly, there are examples of house cats that have gone on 38 years. On the long side of things, perhaps the oldest known species are the pine trees in California called bristletone, spines that can last nearly 5,000 years. Greenland sharks can go over 500 years. And elephants, despite their reputation, have less longevity than humans. For our body weight, we have incredible longevity. But for us, in terms of observable limits, it's 122 years. Now, do we know whether we can go beyond 122 years? We'll only know when we know. We'll know when we see the proof of the pudding. Steve and I believe there's plenty of evidence that we can extend that into hundreds of years. Next slide. About the consequences of aging, I'll just say some things. The efficiency depends on declines of all body systems, decline with advancing age. Steve advanced me. We're going to run through these quickly. Stem cell senescence increases, cell differentiate capability decreases, immune response decreases. There's declines in key hormones. Continue, Steve. There's decreases in numerous key proteins. Continue, please, Steve. Decreased antioxidant defenses, decreased DNA repair capabilities. It all amounts to metabolic pathways get less efficient. All of these factors in a long list of things go on as aging increases. Next point, it all amounts to an incremental decrepitude as you get older. Next slide. All susceptibility to all diseases increases, especially the decreases of advancing age. About 97% of people who've reached my age is suffering seriously from one of these terminal inflammatory diseases of old age. I'm not. I don't think that's just by accident either. Let's Next point. I'm going to show you a lot of curves that shows that as advancing age, the probabilities of diseases and disastrous events increase. Next slide. These are malignant cancers, again, as a function of age. Probability goes up. Some of these things are going to get you. Next slide. Parkinson's disease, dementias. About 92% of people in my age range have dementias. They're in mental institutions or not capable of working or thinking through things anymore. Next slide. There's decline in cognitive capability, and these curves show various memory, reasoning, spatial visualization, speed of recognizing things. Next slide. No longer as sharp as a track. And the lower slide shows declines in various types of reasoning that typically go with age. And you notice these curves only typically go up to 81. I haven't seen any that go up to 94, which is my age. Next slide. Our healthcare costs are going through the roof. Now, this shows an interesting point, by the way, that if you can see that most healthcare costs are for people 70 and over, and you see the curves of different countries, but how healthcare costs go up. If we can extend lifespan by only 20 years, we can cut way down on the costs of healthcare. Next slide. Okay, these are all, again, slides related to fall injuries and other things that go wrong when you get older. Next slide. And this is a growing worldwide problem. It's in all advanced countries. Lifespans have been increasing until last year, where they decreased worldwide due to COVID. Next slide. This is a technical summary of the situation. Next slide. Remember the movie Love and Death with Woody Allen? And that's my philosophy too. I want to be alive. I want to be around. I want to contribute to things. I don't want my contributions to be historical ones. I want them to be current. Next slide. Steve, you want to take over?
Sure. Thank you, Vince. And so let's talk about introduction to consequences of aging and some stats about aging. Let's talk about knowledge related to aging and how scientific knowledge about aging has come to be over time. Let's think about a metaphor. Imagine that a good explanation of aging and rejuvenation in humans is based on knowledge that is cut up into 100,000 pieces of a three-dimensional puzzle. And the puzzle is difficult to put together for three reasons. There is no image of what the completely assembled puzzle looks like on the puzzle box. There's no puzzle box photo, right? So as all this knowledge comes in about aging, there's no obvious place to put each piece of information that's on a particular puzzle piece. The other thing that makes it difficult, another one, is that the puzzle pieces arrive on the puzzle piece. Let's see, I'm gonna do a pen. The puzzle pieces arrive on the puzzle box, the puzzle table at different points in time. There were studies of aging 60 years ago, 80 years ago, and just yesterday. And there's no way to know when the new puzzle pieces will come in. And finally, a few puzzle pieces, as you can imagine, when you're putting together a puzzle, a few puzzle pieces are the really critical ones, or a group of puzzle pieces are the critical ones. And there's no way to know when the critical puzzle pieces or groups of puzzle pieces will come in over time, right? That's how knowledge about aging has grown over millennia, and especially in the last 100 years. There are a couple of interesting questions about the aging knowledge puzzle. How do we go about putting together the puzzle? Imagine all of you worked on really large and complex puzzles before. And one great way to put together a puzzle is to group like puzzle pieces together and try to get them to fit. So we end up with, let's see if I can get this pen to, I can get it to, it's going to be, oh, in color red. Now let's try it. So as you, it's still not
let me just mention a little bit that Steve and I have created a body of research which we call younging. I don't know. Are you done, Steve, or can I?
I got it. So here are the groups of puzzle pieces being assembled. That's really the only thing we can really do, right? If we don't know what the puzzle looks like when it's fully assembled. And there's another interesting question, and the most difficult question. How would we know when a sketch we have, just a pencil sketch, no details filled in, but just a pencil sketch of what the puzzle might look like? Remember, 100,000 pieces, three-dimensional. How would we know when a sketch we drew of the potential completed puzzle is getting close to showing what the completed puzzle actually looks like? Any thoughts about that? One thought is, and we think this is true, is that currently in longevity science, there are a lot of these groups of puzzle pieces, telomeres and inflammation and blood circulation and declining immune system. And there are groups of these puzzle pieces that look to be important, and we've assembled them, but there's no explanation of how these groups fit together so that there is an integrated theory or explanation of how aging and perhaps rejuvenation actually takes place. So we think that it's possible to believe that we're getting closer to really understanding what aging and rejuvenation is about in terms of scientific explanation, when the explanation begins to encompass all of these small puzzle piece groups. And we think that in the two lectures we do, one today and one on Tuesday, we're going to describe two elements of what we think is a first cut at the pencil sketch. And that is called younging. Vince?
Yeah, we've spoken about this extensively, and cutting through a lot of stuff. We are looking for things that are universal, that apply across a number of aging phenomena and a number of natural rejuvenative phenomena, and that explain a number of interventions which make people healthier and extend lifespan. And we're going to deal with two of those in this lecture. The one of the activation of the nervous system via something called the vagus nerve, and a biological mechanism known as the inflammatory reflex. And in our following presentation, we will deal with something that may sound mysterious now. It's demethylation of histones at a certain position via a certain universal demethylase, which is a process which activates hundreds or simultaneously activates hundreds or thousands of health and longevity genes. Again, we have written extensively about this. If you have a look at our blog, www.agingsciences.com, you can find many, many articles about these topics. Thanks. Steve?
All right. So we are going in this talk, we're going to talk about one of the two key mechanisms. Maybe there's a third. We cannot find a third major mechanism for rejuvenation in the scientific literature. There might be, but today we're going to talk about one of them. And before we do, let's talk about a couple of theories of aging and their common assumption. One is called the damage theory of aging. Basically, it's that aging, the damage theory of aging basically holds that aging is the result of damage to cells and organs, and we must repair the cells and organs to prolong life. Another theory of aging is called the programmed theory of aging. And the basic idea here is that programmed aging refers to the idea that senescence, or decline and decay and death, in humans and other organisms is purposely caused by evolved biological mechanisms to obtain an evolutionary advantage. In other words, there's actually an aging program in us that directs aging as we get chronologically older. Now, there's a single assumption that underlies both of these theories of aging, and it is that evolution has established nothing in us, nothing within humans that we might consciously and deliberately trigger to increase health and longevity. But the question is this underlying assumption true? Do you and your family and friends and all of us have mechanisms within you and within all of us that we could consciously and deliberately trigger to slow aging, reduce inflammation, and bring about good things? We think that the answer is yes. And because the answer is yes, we think these theories are false. They have to be false if the answer is yes. And what we believe is that the fact of the existence of this thing called the inflammatory reflex in humans means that evolution has established at least one mechanism within us that we can consciously and deliberately trigger to increase survival probability. And today we're going to talk about what the inflammatory reflex is, what the evidence is about it, and how we know it does increase survival probability when it's triggered. That's the purpose of today's lecture. So the inflammatory reflex is a label identifying a set of biological functions first written about in the journal Nature in 2002 by a professor called named Kevin J. Tracy. And the acronym, and I'll use the acronym a lot because it's easier to say and shorter sentences come about when I use the acronym. TIR, T-I-R, the inflammatory reflex, is a set of mammalian organs, nerves, cell types, receptor types that together perform significant health and longevity inducing biological functions. Say this a different way. TIR, the inflammatory reflex, is a set of mechanisms that exist only in mammals whereby dangerous conditions of inflammation are recognized by the nervous system, and the nervous system automatically triggers powerful responses to reduce that inflammation. I think Dr. Coehlo told me that you had talked about inflammation in the class, and that autoimmune diseases and how inflammation could do damage to humans and other mammals has already been talked about. So the inflammatory reflex is a mechanism that we can trigger to reduce the negative potency of autoimmune diseases and inflammation. That is its functional purpose. Having said that, despite how important reducing inflammation is, and despite the fact that we're going to argue that the inflammatory reflex exists in humans, knowledge about TIR is virtually nil in health professionals and longevity science enthusiasts. No one knows about it, even though the first article about it was written in or published in 2002. So in order to understand what the inflammatory reflex is about, it's first necessary to understand what a biological reflex is. Consider this diagram on the right. Here are the numbers: 1, 2, 3, and 4. And at position 1, you can see that a receptor in the finger detects a heat stimulus. Right? The finger hits the candle. At 2, a sensory neuron that reaches to the spine is associated with the neuron that is triggered by the heat stimulus. At 3, there's another neuron called an interneuron that establishes communication and action intelligence with a motor neuron, and that's 4. And the motor neuron is the neuron that, when the heat stimulus is triggered, the muscle pulls the arm away from the heat stimulus. The 2 key concepts here are a sensory neuron that sends signals from the periphery of our bodies to the spine or the brain, and a motor neuron which originates in the brain or in the spine and takes action in the periphery. That's the difference. Interestingly, the longest neuron, axon, of a human motor neuron can be over a meter long. And that motor neuron is from the bottom of the spine to the toe, right? The bottom of the spine initiates action that takes place in the toe. And a sensory neuron can have axons over 1.5 meters in adults. And that's again from the feet to the spine. Any questions about that? This is essential to understand the inflammatory reflex. Motor neurons and sensory neurons, just one point. Many times, a sensory neuron is called an afferent neuron, and motor neurons are called efferent. So let's take a conceptual view of how what I just described related to the biological reflex is related to this thing called the inflammatory reflex. So on the biological reflex, we have the sensory neuron, and the inflammatory reflex has a comparable sensory neuron, although it's sensing different things than different stimuli than the biological reflex is. And then there's the interneuron. And then in the inflammatory reflex, the motor neuron conceptually is actually implemented in a set of biological objects. And the print is sort of small here. So I've typed out on the right what these elements are that constitute the motor capabilities of the inflammatory reflex. We have the vagus nerve, and then the splenic nerve, and then acetylcholine transferase T cells, and then the neurotransmitter acetylcholine is expressed, and then macrophages are impacted. This portion of the motor arm of the inflammatory reflex is in the spleen. And let me get myself over here, move the picture. And the tear motor arm is also called, the acronym is CAP. The motor arm of the inflammatory reflex is called the cholinergic anti-inflammatory pathway. And we're going to focus, most of the rest of the discussion is all about the cholinergic anti-inflammatory pathway. The acronym is CAP. Again, that's this portion of the diagram. The purpose of the cholinergic anti-inflammatory pathway in this portion of mammalian organisms is to reduce inflammation in the blood circulation. Let's take a look. Let's take a look now at how this conceptual neuronal view of the inflammatory reflex is actually finds itself implemented in mammals. So this is about the CAP motor arm concepts to physiological objects. The source of triggering the cholinergic anti-inflammatory pathway is something called the muscarinic acetylcholine receptor, the M1 receptor in the brain. And that can be triggered by substances that promote or agonize the M1 muscarinic acetylcholine receptor, or you can take an acetylcholine esterase inhibitor. Acetylcholine is the neurotransmitter in the brain that triggers this anti-inflammatory process called the cholinergic anti-inflammatory pathway. Acetylcholine esterase reduces acetylcholine, and if you take an acetylcholine esterase inhibitor, acetylcholine levels in the brain remain higher. Now, the motor arm, we're interested in the motor arm called CAP. The motor arm is in blue in this diagram, from the brain to the spleen. It also interfaces with the heart and the liver and the intestine. And in this, the way these diagrams work is that the spleen here, right? The spleen here is shown as the spleen here in this blown up diagram. And you can see that in CAP, when CAP is triggered, acetylcholine is expressed in the spleen, and that's right here. And in the spleen, this is a cell. So what we have in this set of diagrams are various different sized biological objects, from large organs to one particular organ, the spleen, the intestine, and the liver. And now they all have cells called macrophages, which are bacteria. Basically, they consume bacteria and kill bacteria. And the macrophage cells are triggered also with acetylcholine, and this process reduces cell inflammation in the spleen. Now, why is that important? Well, it's important because the blood circulation system traverses the spleen so that when blood flows through the spleen and the macrophage cells are less inflammatory, it turns out that inflammation is reduced throughout the blood circulation. That's a lot to absorb. Any questions about that? So it's all clear, okay. I think those are the things we wanted to talk about there. Now, has anybody heard of the cholinergic anti-inflammatory pathway and this this brain to spleen mechanism mediated through the vagus nerve that reduces inflammation throughout the blood circulation? One of the few medical professionals I've met who actually knew what it was Dr. Coehlo, actually, which was interesting. The cholinergic anti-inflammatory pathway is complex, but it's not obscure. Hundreds of scientists in hundreds of studies have worked to understand it, but CAP is still not generally acknowledged and leveraged in establishment, scientific, and medical communities. And the amazing thing about it not being well known is that the cholinergic anti-inflammatory pathway is positively potent for increasing health and increasing survival probability. And now we're going to begin to look at, so that's the cholinergic anti-inflammatory pathway. There are more details that we could add, but for lack of time, we won't be doing that now. What we're going to look at now is the evidence about how the cholinergic anti-inflammatory pathway actually increases survival probability. How do we know that it does? Is it positively potent for increasing healthy longevity? Well, there are a lot of studies that show that it is. And what we know is that the survival probability findings in 5 studies, 3 about poisoned rodents, 2 about elderly humans using different intervention techniques, are all best explained by a single biological mechanism, that is the motor arm of the inflammatory reflex, CAP. It's also the cholinergic anti-inflammatory pathway. The studies with graphic figures showing increases in survival probability are shown in red if they are about animals. And there are 2 studies, well, there are more than 2, but 2 studies that existed at the time I put this together in humans showing that it increases survival probability. We know that this mechanism is in all of us unless unless people have some sort of genetic abnormality that makes it not work. And I'm not sure, Dr. Coehlo, are you aware of what percentage of folks don't have a spleen or the vagus nerve. I think it's probably rather small, right? 5–10% maybe?
Yeah.
Right.
Less than 10%.
So it works in all of us pretty much. Let's take a look at a couple more slides about what's happening. The vagus nerve complex is the key nerve of TIR. The dorsal nucleus of the vagus nerve is a cranial nerve nucleus in the medulla that lies ventral to the floor of the fourth ventricle. You can see the root of the vagus nerve is here, and it runs down the neck close to the major vein going through the neck, which I can't remember off the top of the name of it.
The jugular.
Yes. So it begins here and goes through, and then the major vagus nerve goes down the neck. Now, the vagus nerve should not be thought of as being something like should be thought of as an undersea cable with lots of fibers in it carrying signals. And it's not a single wire. When it's coming out of the brain, there are something like 100,000 individual vagus nerve fibers. 80% of them coming out of the brain are sensory vagus nerve fibers. That means they're bringing signals from the periphery of the organism to the brain, and about 20% of them being motor arm signals. That is, the signal is coming from the brain to the periphery of the body. Kevin Tracy once said in a talk, I don't know if this was ever documented in a study, that about 50 cholinergic anti-inflammatory pathway fibers existed between brain and spleen. This picture here is a cross-section magnified, I don't recall how many times, magnified of the vagus nerve, and each major, see this major block here, that is a group of vagus nerve fibers, right? It's a group of them. It's like cable, and there are sub-cables within it that contain individual nervous system fibers. They're not actually called fibers, they're nerves. And that's the cross section. And this picture here in the middle is one of the better pictures showing that in the vagus nerve, the root of it is in the brain, and then the signals come from the brain out to the periphery of the body, and the signals in the periphery of the body that are sensory vagus nerves, they go from the periphery to the brain. And you can see that because the vagus nerve is something like an undersea cable, that at various portions, some subgroup of vagus nerves branch off into address to be associated with some particular organ and send signals to and from a particular organ. Make sense? Any questions about that? All right. And all right, the brain, the vagus nerve connects the brain to a lot of organs: the heart, the liver, the kidneys, pancreas, the intestine. And we're concerned today only with the brain connection to the spleen. Again, why is the spleen important? Let's find out. TIR plays important roles in mammals. Question is, why are the vagus nerve and splenic nerve fibers from the brain to the spleen important? And the answer is that because the spleen is a part of the blood circulation system. Also, the spleen is understood to contain about 50% of the inflammatory cytokine cells called macrophages. And these cells can exit the spleen and flow through to the blood circulation in either an inflammatory state or an anti-inflammatory state. So these cells called macrophages, my favorite metaphor that makes sense is that these macrophages either are bacterial fighters and they consume bacteria. So you could think of them as soldiers being with a barracks in the spleen. They're at the ready to enter the blood circulation system and fight bacteria throughout the mammalian organism. But of course, because inflammation is often overexpressed in autoimmune diseases, so-called autoimmune diseases especially, the macrophages do damage not only to the bacteria, but also to healthy human and other mammalian cells. And when a macrophage is in an inflammatory state, when it's a bacterial fighter, that we call that thing a phenotype, and it's an M1 macrophage. Also, macrophages can exist in what's called an M2 phenotype. And when they're in an M2 phenotype, you can think of them as UN peacekeepers, right? They're not so focused on fighting bacteria and consuming bacteria to get rid of it, but to calm inflammation and assist with the healing process from the inflammation that got rid of the bacteria. The brain to spleen mechanism, the CAP, provides the means, provides a basis, think about this, for cognitive controlled inflammation reduction throughout the organism via the blood circulation. And I don't think anybody raised your hand when I asked, have you heard of the cholinergic anti-inflammatory pathway? That's a remarkable thing. There are ways by triggering this mechanism in the brain to reduce inflammation through the blood circulation throughout the body. An amazing phenomenon. Now, I have found in all that we looked earlier at diagrams of the cholinergic anti-inflammatory pathway that you can get to by Google. If you just go to Google and say cholinergic anti-inflammatory pathway and hit images, you'll see hundreds of different diagrams of its architecture and design and details and so on and so forth. And here's one of them that shows the brain being the focus of it. Here's this celiac ganglion. This is the, you could call it a junction where the vagus nerve splits off into a group just with those nerves that address the spleen, and then the splenic nerves takes over. Here's the spleen. Here is a particular, here's the spleen, and here's a portion of the spleen, and here's a macrophage cell. And through this process, inflammation is reduced in that macrophage. It's transformed into a, UN peacekeeper sort of cell. But none of these diagrams show the key point, right? The key point is not to just reduce inflammation in the spleen. The point is to show that really a part of the cholinergic anti-inflammatory pathway is the blood circulation system itself, right? But if you look at those diagrams, you won't see the little red line going through the spleen, making it clear that the purpose is to reduce inflammation throughout the body. Now, okay, here is, how do we know that the cholinergic anti-inflammatory pathway increases survival probability. That's an amazing thing, right? If it actually so reduces lethal inflammation that if you trigger it, more animals will survive than die. So in one experiment performed in, I think it was published in 2014, a drug, xanomeline, which is an M1 muscarinic acetylcholine receptor agonist. In other words, it promotes the activation of the muscarinic acetylcholine receptor, shown here in the brain. Did some experiments using that drug to assess the capability for CAP to increase survival probability. In the first experiment with mice, the mice were divided into 4 groups, 5 to 7 mice per group, and xanomeline in 5, 10, 20 milligram per kilogram injection treatments 1 hour before lethal or extremely harmful toxin was administered, right? First, we administer the drug that triggers the cholinergic anti-inflammatory pathway. An hour later, we inject the mice with endotoxin. And what we find is that xanomeline, in a dose-dependent way, reduces serum TNF versus just saline, right? TNF stands for tumor necrosis factor, and tumor necrosis factor is another key inflammatory cytokine that circulates in the blood circulation and causes harm to healthy tissue. And you can see that in this diagram, the saline, with the saline group of mice, saline administered group of mice, serum TNF was high. If 5 milligrams per kilogram of body weight was administered, it was lower than saline. It was lower still if 10 milligrams per kilogram of body weight was administered, and it was very, very low if 20 milligrams per kilogram of body weight was administered. And that's remarkable because TNF is one of the key inflammatory cytokines that underlies autoimmune diseases. Now, this is where it gets really interesting. In another experiment, there were 3 groups, 17 to 20 mice per group, and xanomeline in 5 and 20 milligram per kilogram injections. Again, same thing, 1 hour before endotoxin was administered, and xanomeline dose-dependently improves survival versus saline. Let's take a look at the graphic to see. Oh, I need to move. Anytime I'm not moving the photo because it's hiding some key data, let me know. So in this diagram here, here's xanomeline in 20 milligrams per kilogram of body weight. The drug is administered at time 0, and then 1 hour later, is that right? Yeah. Say 1 hour. If the mice got 20 milligrams per 1 kilogram of body weight, all of them survived. If they were given saline, what is that? 10 to 15% survived. And if they were given xanomeline in a 5 milligram dose, again, similar to saline, only about 10 to 15% survived. What does that show? It shows that xanomeline increased the intervention here, right? The intervention is the drug xanomeline. We know what xanomeline does in the body. It's an M1 muscarinic acetylcholine receptor. We know that receptor triggers the vagus nerve. This is an experiment which shows that the cholinergic, it doesn't show that the cholinergic anti-inflammatory pathway through the vagus nerve is the mechanism. There's another experiment which I'll show that shows that. But we do know that hitting the M1 muscarinic receptor increases survival probability. Any questions about these details? I'm going through this in detail so you see that the evidence for the potency of CAP for increasing survival probability is high. Now, here's another amazing experiment. CAP triggered by the hookup acupoint increases survival probability. Now, there's an acupoint right here, and it's called, I can never be sure I'm pronouncing it correctly. Hooga, right? Or close enough. I used to call it Hegu, but Hooga acupoint right here, and it has long been known as one of the most positively potent acupoints in acupuncture. And here's a diagram of where it is here on the left. There's the Hooga acupoint. They also, in the experiment, hit the Neguin acupoint, and it is right in here on the arm, as you can see here. Let's talk about this experiment. All the photos are clear. Check on my time here. We got time, right? Yes. Oh, we're another half hour. Is that right? Okay. Electroacupuncture 4 groups, 20 per group. Administer electroacupuncture 45 minutes before and at 1 and 2 and 4 hours after lethal endotoxin. We use two known acupoints, Hooga and Nguyen, and a sham point. In other words, just randomly pick a point on the body to do electroacupuncture. Lethal LPS is sent, and the rodents that got the Hooga acupoint injection, 80% of them survived. If there was no, if they just got the lethal endotoxin and no acupuncture was done, 20% of them survived. And if they got a sham or a random acupoint, acupoint injection, also only about 20% survived. And this is, as you may recall, this is the same result we saw with xanomeline. The question is, how do we know that these two experiments both triggered the cholinergic anti-inflammatory pathway through the vagus nerve? And I'm going to speed the pace up here. A form of this, of the logic of this general experiment has been performed dozens of times in various experiments. And this is just one kind of example. I'm going to walk through it quickly. 4 groups of mice. For each group, do something to the mice in the group and then perforate the intestine. And perforating the intestine, bacteria gets into the blood circulation system. The immune system is triggered. Macrophages flow into the body to fight the bacteria. And that's the purpose of perforating the intestine, to assess the effects of overwhelming inflammation. In the control group, do nothing. It's because it's the control group, and then perforate the intestine. And that's this group, this experiment here. Inflammation is very high. Here's the mouse. Perforate the intestine, and infection is created, inflammation results, and almost all the mice or rodents die relatively quickly. Another way to do the same experiment is cut the vagus nerve, right? And what this would do, cut the vagus nerve and its connection to the spleen. And what this does is to test to see if in fact the mechanism of action to increase survival probability is through that splenic mechanism that sends macrophages out into the blood circulation, either in an M1 or M2 phenotype. So in experiment B, we have the mouse, we cut the vagus nerve connection from the brain to the spleen, we perforate the intestine, and infection results, inflammation results. Inflammation is higher, and the rodents die faster, which is amazing. Group 2 put an electrode on the vagus nerves connecting brain to spleen, and trigger a microcharge to it, then perforate the intestine. Inflammation is dramatically lower, and most of the mice survive. We have the mouse, we put an electrode on the vagus nerve, fire it up, perforate the intestine, infection results, inflammation is less, more of the mice survive, or the rats survive. We can also administer acetylcholine and then perforate the intestine on the same result. Cutting the vagus nerve, because we did an experiment where we cut the vagus nerve, we know that the vagus nerve connection from brain to spleen is essential. It has to be intact for the survival probability benefits to be achieved, right? Any questions about that? Okay, that's all well and good. The cholinergic anti-inflammatory pathway increases survival probability in mice and rodents and in rats. What about humans? Well, there was a study published in 2014. The study title was Effects of Galantamine in a 2-year randomized placebo-controlled study of 2,000 plus elderly patients in Alzheimer's disease. Galantamine is an acetylcholine esterase inhibitor. It increases acetylcholine in the brain that can trigger the vagus, and has been shown to trigger the vagus nerve via that M1 muscarinic acetylcholine receptor we talked about earlier. And the results were the placebo group and the galantamine group of patients were roughly the same size. The average age was 73. 32 patients completed the study, 27% withdrew, and 1% did not complete the study. Why? Because before the experiment started, they decided at 2 years, we're going to unblind the data to see if there is good reason to stop the study, the clinical trial, because galantamine was having such a positive effect or a negative effect that we would know it would be unethical to continue. And what they found, as you can see in this diagram, this bottom line, that's the survival probability curve of the elderly getting the placebo, and the people getting galantamine over a 2-year period survived in a statistically significant way. So the study was halted after 2 years because it would have been unethical to continue. It's unethical to continue to do the study if so many elderly potentially suffering from Alzheimer's were surviving when those who weren't getting galantamine died. That's an amazing thing, right? I buy galantamine on Amazon. I like the pure encapsulations version of it. In this study, they took 4 milligrams, 8 milligrams, 16 milligrams per day galantamine. It's on the expensive side, but it increases survival probability in a profound way. And we know in other studies that galantamine triggers the cholinergic anti-inflammatory pathway. I'm sorry, what?
I'm so sorry. You said you could buy it off the internet?
Yeah, you can buy it. You can buy it on Amazon, iHerb. You can buy galantamine most anywhere. Yeah.
Is it like a supplement or something?
It's a supplement. That's
Oh.
right. That's right. It's a supplement. And it's an acetylcholine esterase inhibitor, right? It's not an M1 muscarinic acetylcholine agonist or promoter triggering that receptor. It just increases acetylcholine in the brain. By the way, I'm wearing this device. You see this light going on and off. I'm wearing this because this device can be used to also increase acetylcholine in the brain. If a lot of places, if you look for galantamine, you'll see that it is a supplement to take to increase what's called lucid dreaming. Lucid dreaming is the state where you're dreaming and you're dreaming, you know you're asleep, you're dreaming, and so you're kind of aware. That's lucid dreaming. Galantamine is used to increase lucid dreaming states, and we can talk about this device a little bit. So that I know that this also is also hitting the M1 muscarinic acetylcholine receptor. Yeah.
I'm just curious, have you experienced more lucid dreaming since you've started trying to increase it yourself?
I just got this device called the HAPBE, HAPBEE. I just got this device 4 weeks ago or something like that. And I have noticed a dramatic increase in lucid dreaming since I got this device. And I love that because I know it's triggering the muscarinic M1 receptor, because that's the purpose of galantamine, right? So essentially, I got this on sale. If you contact me, I'll give you the coupon code to get 40% off. Cost me $240, $250. But basically, I'm wondering, do I need to take galantamine? Just get this device and run it. And the mechanism by which this device increases acetylcholine in the brain is a different thing. We won't hit that today, but Vincent and I are pretty certain that's what it's doing, because it is increasing lucid dreaming. I'm going to move very fast. What time is it? I need to move quickly. Parabiosis plasma dilution experiments confirm the importance of blood factors in aging. There have been experiments. The circulation system of two rodents are sewn together in a way, and the older one gets younger, the younger one gets older. And it's also been shown that diluting plasma in circulation, so plasma dilution, also increases younging factors. Here are some ways that one can trigger the CAP and its benefits. And you'll recall, I think you have a link to the slides, right? To the PDF.
Yeah, it's posted under module 11.
Right. So you'll have these slides. You'll remember on April 9th, Vincent and I are going to do a talk for the London Futures meetup. And that meetup is going to be all about we're not going to talk about, what the mechanisms are. We're just going to talk about the interventions. And this device is going to be featured in our talk because we're finding it really works in a profound way. But you can look at that. How you doing, Vince? You have some thoughts? Triggering the CAP and its benefits. This particular slide has links to blog articles on Vince's anti-aging firewalls site. And we can use photobiomodulation, PEMF, and we'll be talking about this again at the London Futurists meetup in April. And we'll also talk a little bit about this in the talk next week. I'm moving quickly here. Okay, what does this mean? It means that our hypothesis that mechanisms do exist within us that we can consciously and deliberately trigger to increase survival probability. That's true. We have this mechanism, evolution established it within us. One of those mechanisms called the cholinergic anti-inflammatory pathway. Last prose poem I wrote about it. gosh, 5 years ago now. Summary 2. Sometimes many therapeutic innovations, ancient and modern and conventional and alternative medicine, have been shown to be highly effective in promoting health and longevity. But only recently have we discovered their actual biological mechanisms. The ancient Asians in East Asia, they were triggering the Hygge acupoint thousands of years ago. Now we know why it was. Now, only 20 years ago, did we kind of figure out, oh, so this is how it works.
Yeah, it's a key comment here.
Yeah.
We're not covering is that there are a number of highly practical, actionable interventions to stimulate the cap and stimulate the vagal nerve. The system Steve is showing, wearing on his head is one of them. And we're going to deal with all that. And
Here's the other. Yeah, absolutely. Well, we're going to talk about them. I want to leave time for a few questions at least. False beliefs inhibit actually learning and growing. There's a new concept called the adjacent possible. The idea originated from Stuart Kaufman in 2002. The adjacent possible is the knowledge next to what we think we know and which offers rich possibilities for further discoveries. So in this diagram, the darkened dots are these are actual, think of them as knowledge nodes. And this image is looking at knowledge, top down. It's just a node. It represents some block of knowledge. And the adjacent possible are nodes of knowledge. We don't know for sure that it's true, but we think these is a way to expand our knowledge. And we're going to talk about the Copernican delay next talk. Now, suppose the knowledge node in the center of the diagram, right? Actual knowledge. Here's the adjacent, here's what we know. Here's an idea of what might be true. Suppose our idea about remote possibilities, what do we think happens to remote possibilities when the key adjacent possible node turns out to be false? Remember that assumption underlying those traditional 2 theories of aging? The assumption was that evolution has established nothing within humans that we might consciously and deliberately trigger to increase health and longevity. Because we now understand the cholinergic anti-inflammatory pathway, we know that belief is false. So how does that get in our way? Think of it like this. Here is the belief we've just figured out because we understand the cholinergic anti-inflammatory pathway. Here's the belief that's false, and here are the possible new knowledge that might be achievable if it were true, but it's false. And look what it does. Because so many people are taken up with this false belief, it's hiding the significance of the cholinergic anti-inflammatory pathway for increasing health and longevity. And think of it like this. False beliefs, all false beliefs, they ooze a kind of cognitive fog, just like fog in the trees. If there's fog in a forest, it's hard to make out what kinds of trees, how many trees, what kinds of trees, and what the other landscape is when there's fog. And false beliefs create a fog, a kind of cognitive fog. And we think that's why, after 20 years of studies about the cholinergic anti-inflammatory pathway, most medical professionals, most scientists still don't know what it is. It's a remarkable thing. And with that, But how about any questions?
Right there, that's
Yeah.
all false beliefs or.
Well, I think I have a radical view about this. I mean, I consciously look for false beliefs and try to eliminate them. If you eliminate false beliefs, you not only figure out what not to believe, but you have potential to learn more. That's my personal feeling.
All false beliefs are potential to learn.
Yeah, I mean, Dr. Coehlo may have opinions about that too. I don't know what she thinks about that.
Yeah, we need to identify false beliefs in order to learn what is
Yeah.
more likely to be true.
I captured all false beliefs are like fog in a forest, which prevents us from seeing alternative answers.
Seeing alternatives, because we're so focused on this belief, it's shaping how we think about reality, that we can become unaware and we don't perceive other potential beliefs. There's a new book out published in the last year by a neuroscientist named Anil Seth, who's in the UK. The book is called Being You, A New Science of Consciousness. And he says that if we have a belief about how the world works, it can often be very difficult for us to interpret data in any way other than what is already confirming what we believe. Yeah.
So sort of like related to that, I think you said that you're a software engineer.
Yeah.
So I was wondering how like that may have influenced your work, because I think it's like, as you said, it's like less conventional, I guess.
Right. So a way that I think about this is that, it's just like all software engineers. I write code that has errors in it. And finding errors is the key to getting things to work. And the way it's helped me in doing this longevity science research is, I'm pretty good at diagnosis in software engineering, going into a room and learning about some business problem that needs to be solved. And I need to figure out what are all the problems that exist? How should I think about this? And so asking diagnostic questions, creating hypotheses, and then testing them, and abandoning false beliefs ruthlessly. Ruthlessly looking in myself, in my personal life and professional life, looking for them ruthlessly and giving them up trying to give them up as soon as I know it. That's how it's.
Sense.
I had a question on that.
Yeah.
In the beginning of the statement there, it talks about the inflammatory reflex, and it named off a whole bunch of diseases.
Right.
So if we could circle back to how does this affect those inflammatory diseases?
The inflammatory reflex has been shown to be helpful with arthritis. And I don't have the diseases. I think the list of diseases that you put up, Vince, was more general and not just related to the inflammatory reflex, but it might not have been. You know what? We'll have a slide for that next talk. I don't know that we have it available today.
You really have not talked about the practical applications of addressing the CAP. It turns out that acupuncture addresses it.
Right.
Drugs like galantamine. Many ancient meditative practices, such as breathing techniques, address it. Neural sound stimulation, such as via devices that are available now. The whole field of electromagnetic stimulation, of pulse therapies and currents, infrared light, and dietary substances address it. So we haven't really looked at the evidence of how this works out in the real world. We've Steve focused, I think, doing a great job on the principles and the theories and sort of a couple studies that gave the proof. But all I can do is ask you to believe that it's there. Look at our blog, look at London Futurist and the following presentation, and we will be giving you more.
We'll have it. So this is, you may have noticed, this is the version point. This is version 0.9 of this talk. I will throw in another slide showing the specific diseases and disorders that the cholinergic anti-inflammatory pathway has been specifically shown in some study to help to address. I'll have it in a slide just for that.
And then what I'm interpreting is that you're saying those diseases are an inflammation of the body,
Correct.
and they're on the central nervous system.
The diseases, any disease that is considered an autoimmune disease, theoretically, the cholinergic anti-inflammatory pathway ought to be helpful for that disease. So I think that's true in principle. What I don't know, so I would say all autoimmune diseases. What I don't know is the complete list in which a specific study triggering the CAP was done for some list of diseases. I'm relatively certain there are at least 10 to 20 different disorders for which the CAP has been studied.
So I hear that the information that you're providing today, that the studies are chasing the newness of your findings.
I didn't understand the question.
That this is coming first, and then the studies on the impact of those diseases is going to happen, or is happening, but has been.
Yeah, specific studies have actually been done about specific diseases. And I will have a list of the diseases along with a link to a specific study that looked at the CAP and the disease. Any other questions? Well, thank you very much. Coehlo, thank you.
We'll learn more next week.
Is there one other question? Is there a particular brand that they're looking at?
Galantamine, I like Pure. There's a brand called Pure Encapsulations that I like. And on Amazon, you can get the Pure encapsulation 4 milligram tablets for $90. And I'm taking one today. And I didn't feel it. Actually, I'm looking to save some money by using this device. And we'll have more information about how useful this device is at the one in the future.
Is that something you work 24 hours a day, or is it something you're just?
I'm just wearing it for show today. You know, it doesn't, I mean, I just forget that I have it on. But it also is incredibly helpful for sleep.
You wear it at night and then just get all the benefits, or is it something you wear for 2 or 3 hours?
I wear it for 2 or 3 hours, and I begun to wear it around all the time, except when I'm charging it, just because it's good to have. It has a mood. You can trigger a good mood out of it. Also, that actually works. Yeah, it's pretty amazing.
Just curious to be like, how long do you have to use it?
I think for every different cut, basically you could think of it as the menu is a list of cognitive states you might want to go into, either sleeping or pain reduction or stress reduction, happy mood. There's something like 15 to 20 different cognitive states that it can help to trigger. It's-
Is it something like the blue light, is that something similar, or if it's altering the mood, is it gonna? create
Blue and red light is
that happy light
is
that they
kind
want?
of similar in a way, in that it is kind of similar in one way in triggering a specific biological object.
Mhm.
But actually, I think, Vince, that it's confusing about some of these devices, whether they're triggering the mitochondria or the cholinergic anti-inflammatory pathway.
Sounds a little bit like it's hitting against the serotonin.
Oh.
Yeah,
which can be both.
yeah.
Right.
Good questions.
Definitely a topic. I have a daughter with diabetes, you know, and if she has any ability to benefit from this, I would get it for her in tonight kind of.
I'll look into diabetes and see if there are some studies, and I'll come up with the list.
That would be great. 'Cause if
Yeah,
it's something that
absolutely.
Is happening and then the science is chasing it. I'm all for helping. Let that science chase it.
Right.
By going, "Oh, my daughter," you know, type of
Yes.
thing. And
Well, Mr. Giuliano,
that's an Alzheimer's
thank you.
run- An Alzheimer's runs in my family. And if
Good to see you.
I don't know.
Did you see me? I don't know if am I showing up on that?
Yes, you should be.
Oh, there I am. Yeah, I love that.
Thank you, Vince. That was
Thank you,
great.
Vince.
Thank